Hello again. We are starting chapter 10. We only look at sections 10.1 through 10.4 here. Parametric equations and polar coordinates. We're going to start with parametric equations, curves defined by parametric equations. What is a parametric equation? It's a different or a new method of describing curves for, number one, curves that are not functions, and number two, curves that are better described using a third variable called parameter. So let's see how this works. In problem, let me look at page, we're on page 668. So on problem 3, on 668, we're asked to sketch the curve by using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases. So we are given that x equals 1 minus t squared. We are given that y equals 2t minus t squared. And we are specifically told that t, which doesn't have to be time, is just a third parameter, between -1 and 2. So first we're asked to sketch the graph, sketch this curve. So we will have to create a table of ordered pairs with x, y, and t. T is our starting point. So we always start with t, and then x, and then y. T goes from -1 to 2. -1, 0, 1, and 2. Nothing else. Good. So now I will plug in -1, 0, 1, and 2 in x, and then in y, and determine the corresponding x and y coordinates. So 1 minus 1, because -1 squared is 1, 1 minus 1 would be 0. When I plug in 0, I get 1. When I plug in 1, I get again 1 minus 1 is 0. And when I plug in 2, 1 minus 4 will be -3. Now we plug in the same t values, but in y this time. So when t is -1, -2 minus 1 will be -3. When t is 0, I get 0. When t is 1, 1 minus 1, I get 1. When t is 2, 2 times 2 is 4, but -4 will also be, -4 is 0. Good. So now let's graph. And we start, of course, this is x and y. And of course, we start 0 for x, -3 for y. That's our starting point. 1 for x, 0 for y. And that's the direction. 0 for x, 1 for y. And here's the direction, continues. And then -3 for x, 0 for y. And that's the direction. And that's it. As you see, this is not a function, right? So representing it using a parameter was very convenient. Okay, the next recommended problem is number 9. So the same question, but this time they're asking us to sketch, but also eliminate the parameter. So part A, let's copy the problem first. X equals t squared minus 3, and y equals t plus 2. And we are told that t goes from -3 to +3. Okay, so in part A, we are asked to sketch the graph. In part B, eliminate the parameter. And of course, get a Cartesian equation to obtain or get the Cartesian equation. Okay, so let's start with the graph. Of course, t is first, the parameter, and then x, and then y. Specifically, we're told -3, -2, -1, 0, 1, 2, and 3. When t is -3, 9 minus 3 is 6. When t is negative 2, 4 minus 3 is 1. Negative 1 squared is 1 minus 3, negative 2. 0, negative 3. 1, negative 2. 2, 1. And the last one, the same thing, 6. Good. Let's move on to y. For negative 3 plus 2, negative 1. Negative 2 plus 2, 0. Negative 1 plus 2, 1. 0 plus 2, 2. 1 plus 2, 3. 2 plus 2, 4. 3 plus 4 plus 2, 5. Okay, so let's see what we get. Six, negative 1. 1, 0. Negative 2, 1. Negative 3, 2. Negative 2, 3. 1, 4. And 6, 5. How nice. That's how we started. And that's the direction. And we know that this is a parabola with axis of symmetry at y equals 2. Now let's eliminate, this was part A. And now let's move on to eliminate the parameter. And we should get something that reflects the Cartesian equation for this graph. Okay, page 3. Good. So x equals t squared minus 3 and y equals t plus 2. I will solve the second equation for t, moving 2 to the other side, y minus 2, and then plug this in t squared. So then x equals y minus 2 squared minus 3. Clearly, this is the vertex at negative 3, 2. Negative 3, 2. Yes, we can expand, and let's do that. And we have y squared minus 4y plus 4 minus 3, which is 1. This is the equation of the parabola that we see, or conic section, the parabola that we see in the graph. Good. Let's move on to 11. Same question for 11. On the same page, 9 and 11 are on the same page, 668. Good. Moving on. What was it? Number 11, x equals the square root of t, y equals 1 minus t. Good. Notice that this t has to be definitely greater than or equal to 0, as we know, the square root. We can go ahead this time. Doesn't matter the order. Let's graph. Okay. So, and x and y, and of course 0. Okay. So because it's a square root of t, I'm going to use 1 and 4 and 9. Let's see what happens. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Now for y. 1 minus 0, 1. 1 minus 1, 0. 1 minus 4, negative 3. 1 minus 9, negative 8. Good. Okay, so let's start by graphing 0, 1, 1, 0, 2, negative 3, and 9, negative 8. Obviously, we already know what we have. Let's see if we get this by eliminating the parameter, right? So in part B, I will square both sides to get t equals x squared. and I will replace it in the second equation. So y equals 1 minus x squared. And of course, only for x greater than or equal to 0, because this is a quantity that is always greater than or equal to 0. So that's exactly what we have. We have this parabola, right? X squared minus x squared up 1, but only for x greater than or equal to 0. Good. Let's look at a few more examples. So we move on to same page, problem, I'm on page 4. Let's look at 13. In 13 we have x equals 3 cosine t. We have y equals 3 sine t, and they're telling us that t, the parameter is between 0 and pi. We're asked to eliminate the parameter and then sketch the curve. This time they reversed the requirements. Good. So all I can think of when I see sine and cosine, I can just square both, right? So I square both sides here, so I get x squared equals 9 cosine squared t. I square both sides here, y squared equals 9 sine squared t. What I'm going to do to eliminate the parameter is add these two. So x squared plus y squared equals 9 cosine squared plus 9 sine squared. But I know that this is 9 times cosine squared plus sine squared, which is 1. So the Cartesian equation for these parametric equations is x squared plus y squared equals 9, which we know from algebra that this is a circle with a center at 0, 0, and a radius of 3. Now in part B, so this was part A, to eliminate the parameter. In part B, we want to graph. And we start exactly like we always do. 0, pi over 6, pi over 4, pi over 3, pi over 2, pi. I may not need all these, but we'll see in a moment. So x and y. Okay. So I'm going to do this. I'm going to, in y equals, I'm going to punch in 3 cosine x. I'm going to punch in y2, 3 sine x. And then I go and punch in what I need. I need 0. I need pi over 6. I need pi over 4. I don't know what it did here. Pi over 4. I need pi over 3. I need pi over 2. No. Pi over 2. And I need pi. So let's see what we get. We got 3. What did I get? Okay. 4, 0. I got 3 and 0. 4, this is 0.5, 2.6. No. 2.6, 2.6, 1.5. 2.1, 2.1, of course. 1.5, 2.6. 0 and 3, and negative 3 and 0. Perfect. So let's graph this, which we know what it is anyway, but we have to graph according to the given parameter. So I know how to graph this, right? It will be, I'm going to erase this, right? It will be this circle, but I have to follow the parameter. The parameter is only from 0 to pi. So then, of course, we start at 3, 0. We'll continue with 0, 3, and we go to negative 3, 0. And we can plot, let's plot a couple of these two. So 2.1, 2.1. Okay. And this is the direction of the parameter. The way the parameter increases from 0 to pi, this gives us the direction of the curve. Good. Let's see what else we have here. 17 on 669. Same question, x equals e to negative t and y equals e to t. Notice that both of them are strictly positive. So in order to eliminate the parameter, first I'm going to write that x equals 1 over e to t, and I will replace e to t by y. So this is x equals 1 over y, or if you interchange those, we get 1 over x. Good. Notice x and y have to be positive. So the graph of 1 over x, when x and y are positive, is just this. Good. One more, 19. 669. See how interesting the conversion between parametric equations and the Cartesian equation is. How smooth this change happens. And y equals the square root of t, and t greater equal to 1. Okay, so this, because t is greater than or equal to 1, this is greater than or equal to 0. This guaranteed will be greater than or equal to 1. Okay, so let's see how we eliminate the parameter here. So what I would like to do is just, again, square both sides. So I get y squared equals t, and replace t in the equation for x with y squared. So x equals natural log of y squared. So here, any natural log or any log equation can be converted to an exponential. Remember, the base here is e to x equals y squared, or y squared equals e to x, or y equals plus or minus the square root of e to x. Not so fast, because I cannot include negative. Clearly, y is only greater than, or it's a positive number greater than or equal to 1. So then y equals the square root of e to x. And how do we graph this? We start with when t is 1, because t is greater than or equal to 1. When t is 1, x is 0. And when x is 0, y is 1. So this is it. Thank you. I hope this helps.